Hello students, welcome to all of you in my channel name Shubh Chemistry. So today I am going to be discuss a very fundamental portion from thermodynamics, and today I will cover up the small portion of that chapter, that is work calculation in different thermodynamic process. Okay, let me start without wasting any time. First of all, that is thermodynamics, that is our chapter, thermo and dynamics. The name itself, it is given its explanation. What is explanation? That thermo means temperature, and temperature, as we know, it is a one kind of a energy. So energy or temperature we can say. And dynamics is what? Dynamics means movement. So in this chapter particularly we discuss about the energy transformed from one phase to another, and whatever it is changeable. So without wasting any time, let me today's cover is different type of process, and then I will cover up the work done calculation. So thermodynamics means it's very clear, it's very simple, that the energy in form of temperature is moving from one to another. So what is thermodynamic process? Let me describe the different thermodynamics process. Thermodynamics, I already explained its meaning, that is thermodynamics, and I want to explain what is the process. Obviously thermodynamics is different type of process. First of all, we discuss the process. What is the meaning of process? Process means changeable from one phase to another. Let I give you a point, that is the point number A, and it has to go with point number B. If it is described by point number 1, and what can be, it is driven by four temporary factor, that is pressure, volume, temperature and mole. But fourth mole quantities we will fix in this chapter, that is 1 mole. So for 1 mole, if a position is described by pressure, volume and temperature, let's suppose this is 1, and if it has to driven to point number B, so we can it can P2, V2 and T2. So what kind of process? Process means change its three parameter, either in pressure, either in volume or either in temperature. I hope you are connecting to me, and it's very simple and clearing to all of you. So process means that one has to given one from point A to point B. How it is will given? From pressure, volume, temperature to pressure, volume, temperature, but there must be a change. Obviously three parameters are given, so someone has to be constant, either one has to be variable. So what kind of pressure? If pressure is constant, with the help of different three quantities, if pressure is constant, that it is called as a isobaric process. If pressure is constant, it is again. Second one, isochoric process. Let me describe first. Let me discuss all the listed, and then I will explain what about all the process. So isochoric, isobaric, and third one is isothermal process. Isothermal, and fourth one is adiabatic process. Adiabatic process. Okay, so first of all, isobaric, what it is means, if the pressure is constant throughout the process, same like I have to go from A to B point, how I can go? With the help of changing three parameter, either in pressure, volume or temperature. If pressure throughout the process, by doing this from A to B and during this point, if the pressure is constant, then I have to call this isobaric process. Is it fine? Again, if the volume is constant throughout the process, that is called as isochoric process. Is it? Again, if isothermal means temperature is constant, but remember, all the throughout the whole chain there must be constant. It is not that it is point A and point B the pressure is same. Not same. It should be the same throughout the every point of the from A to B. I hope you are clearing myself. Again, what is in adiabatic? In adiabatic, Q, that is heat, is a constant term. So these are the four basic fundamental thermodynamic process, and every process factor constant is given. In pressure is constant, then it will call isobaric thermodynamic process, and volume is constant, that is called isochoric process. If temperature is constant, that is isothermal. If heat is constant, that is called adiabatic. I hope my things are clearing to you. So many doubts. So let me describe how these process practically happen in daily life. Let me give an example. There is a piston or cylinder system. Like that, it is given a cylinder, cylindrical slab is given, and there is a piston. There is a one kind of piston is available. Obviously, it is connected to a pulley or one kind of a rope, or we can apply here a force. If I have to volume is expand, then I have to go force upward direction. If I have to decrease the volume, that the force I will do in downward direction. So what happen? The distance will change. If the d is the distance, if I force upward, then it will change. It means volume is what? Expanding. If I decrease it, distance is decreased, then it will what we call compression. Is it? Again, here is a gas is given. Obviously, 1 mole gas is put here. So I would like to say that this is a practical phenomena, that pressure, volume and temperature, three fundamental factors that can change a position or a position state. If initial pressure is P1, V1, T1, then it can be changed any one thing, only one or two things. One has to be constant. Therefore, if pressure is constant during this process, known as isobaric, and various processes are which I already discussed. Now let me discuss what is how work is defined with help of this practical phenomena. Is it? So what is a work? As we know that work is a force into what? Displacement or distance. It is a physics formula, we can connect it, that work, what is work? Work is a force into distance. So I can write it either F and D for distance, F into D. Is it force that I apply to upward direction or downward direction, and this is a D is a distance. Now if it initial position, again one thing, if I force upward direction, then gas will go downward direction. It means whatever direction the force has, the movement of gases will be in opposite direction. So I have to put a negative sign before force, because I have to calculate this work, not this work. Is it? So I have to put a negative quantity due to direction opposite. Again, this is a distance. Okay, so I have got the formula W is equal to minus F into D. Is it very clear to? It's a very simple. You can connect all these things. Okay, let me do one experiment, that I can multiply with A and divide with A. Is it got anything? It will doesn't change, no? So what I done, I divide with A, that is area, and that is area. Multiply and divide. What is area? Area of piston. This is piston. Like that we have to go with this. So what is can be written? Force upon unit area, that is called pressure. I hope you are connecting to me. These all are physics formula, that force into per unit area, force the unit per area, that is called pressure, and distance into area, that is called volume. I hope you are able to understand what I want to say. So again, this is minus sign. So finally what I get the formula of work done, that is W is equal to minus of PV. Is it? If pressure is constant, then I can write P as a constant, and if volume is changeable, so I can change delta V. Is it? If volume is constant and pressure is changed, then I can write it V as a constant outside and delta P. So I got the three equation of work, either minus PV if work or pressure both are constant. If volume is variable, then I can write it. If pressure is variable, then I can write is. So these all are the work done formula. So it is applied for different kind of process. So let me discuss all the formula with individual process. I hope you are able to understanding me. You are clearing to all concept. Okay, so I described the different thermodynamic process, that is called isobaric, choric, adiabatic, and what? Isothermal. So first of all, I described all the process in PV graph. PV graph, you